Next type of Pfaffian differential equation, reduction to ordinary differential equation. So let Pxyz dx plus Qxyz dy plus Rxyz dz is equal to 0, equation number 1, be a given Pfaffian differential equation in three variables xyz, which is integrable. Then we have to find the solution by using reduction to ordinary differential equation. Then it has a solution. As it is integrable, it has a solution. Suppose fxyz is some function of xyz is equal to c1, capital Fxyz is equal to c1, where c1 is a parameter of constant. The integral surface of to intersect by the plane, suppose this integral surface to is intersect by the plane z is equal to x plus k1, where k is constant. Therefore, the curve obtained by equation 2 and 3 will be the solution of the differential equation. Curve obtained by equation 2 and 3, intersection of equation 2 and 3 will be the solution of the given differential equation. So we substitute pxyk z as z value of z as x plus ky, that is the value of z in terms of x and y, and therefore this p, the function xyz pxyz converted to the function of xy and that constant k dx, that is z is converted to x plus ky. Therefore, we have this pxyz, that is the function of xyz converted to function of xy and some constant dx. Similarly, qxy converted to the some function of xyz, xy and k, dy is equal to 0. And obviously, this dz converted to dz is what? Dx plus k dy, that is dz converted to dx and dy. So we have, this is the new equation after substituting z is equal to ky. The equation, this equation, given equation becomes this. This is the Pfaffian differential equation in two variables. And so every Pfaffian differential equation two variable is integrable, means it has a solution. Suppose phi xy k is equal to c to be the solution of this equation, equation number 4. As this equation is Pfaffian differential equation in two variable, and the Pfaffian differential equation in two variable is always integrable. Therefore, we have, this is the solution. The point axis of equation 2 is obtained by, the point on the axis of the equation number 2 is obtained by taking y is equal to 0 and x is equal to c. Then the equation 5 becomes, take y as 0 and x is equal to c. So we have 5c 0k is equal to c to equation number 6. Then eliminating k from 3 and 6. Eliminating k from 3 and 6. And we get the solution of the equation number 1. We get the solution of equation number 1. So this is the procedure, that is, we reduce this equation to ordinary differential equation and solve the equation. So the example on this method, let solve y plus z dx, z plus x dy, x plus y dz is equal to 0. Obviously, this is a homogeneous Pfaffian differential equation. So we can also solve this equation example by using substituting y is equal to ux and z is equal to vx. Okay, and also we can solve this example by using, by separating that y dx plus z dy, y dx plus x dz, y dx plus x dy. It is the derivative of x into y. That is, we can solve this example by using direct integration. Here we have to solve this example by using this method. That is, we have to reduce this equation in a differential equation in ordinary differential equation. So the given differential equation is this, suppose 1. Then put z is equal to x plus ky. Therefore, dz is what? Dx plus k dy. Dz is what? Dx plus k dy. Then equation 1 becomes, that is, substitute z as x plus ky and and z as x plus dy, and substitute this dz as dx plus k dy is equal to 0. And then after simplification, that is collect the coefficient of dx, collect the coefficient of dy. We have y plus x ky, x plus y dx, and coefficient of dy is this. Okay, and then after simplification we have this 2x plus 2y plus ky dx, 2x plus 2ky plus kx dy is equal to 0. So this is what? This is the differential equation. This is the function of x, y, and k. This is the function of x, y, and k. So if we observe this equation number 4, if we observe after substituting z is equal to x plus ky, the given differential equation converted to this, that the function of x, y, k into dx plus function of x, y into k dy is equal to 0. So this is the actually this is the equation number 4. That is this equation given after substituting z is equal to x plus ky. The equation given equation becomes this. That is the function dx, the function of xy k, and into dx the function of xy into k dy is equal to 0. So we have to solve this example, this equation. Then so 2x dx plus 2y dx plus x dy plus 2ky dy plus ky dx plus x dy. That is the arrangement for the integration. So we can obtain the solution of this differential equation by using direct integration. So integration of 2, this is ky square, okay, 2x dx, 2x dx. So this y dx plus x dy is the derivative of x into y. So it's integration x into y. So this is ky square by 2. 2 to get cancelled. So we get ky square, integration of this factor, 2ky dy integrating. So we have ky square by 2, 2 to get cancelled. So and then integration of 2x is what? X square by 2x square by 2, 2 to get cancelled. So x square plus 2 integration of y dx plus x dy x into y plus k integration of y dx plus x dy is xy is equal to constant of integration, suppose C1. Then from equation 2, we have to eliminate the second this sentence. This is the this is 5 is what is the solution of this equation number 4. So substitute y as 0 and take x as constant. So from equation number 2, this equation z k is z minus x by 1. So from equation number 3, substitute k as z minus x by 1. So eliminate k from 3 and 6. We have to eliminate k from 3 and 6. So substitute k as, this is equation number. So we have to eliminate k from this equation number 2 and this equation number 3. So substitute k as x minus z minus x by y in equation number 3. We have this, and after simplification we have this as answer. We have this x square plus 2xy. After simplification, z minus x is equal to c1. That is x square plus 2xy plus xz minus xy is equal to c1. So zy minus xy, x square and x square get cancelled. So 2xy plus xz, 2xy plus xz is equal to c1. Okay, simplify this. I think something is wrong here. So simplify this. and we get the final answer. We get the final answer. Okay. So just substitute k as z minus x by y in this equation. So this is the procedure to obtain the solution of Pfaffian differential equation by reducing it to ordinary differential equation. That is, substitute z as kxy means dz is dx plus k dy. So the equation reduced to in this form. That is some function of xy k into dx, some function of xy k dy is equal to 0. That is, it reduced to the two variable Pfaffian differential equation, and it is always integrable. So integrate that equation, that is find the solution of that equation, and it is, suppose it is equal to 3, then substitute k as z minus x by y in the equation number 3, we get the solution. Okay. So these are problems from for homework, for assignment. Verify the differential equation this is integrable and find its primitive. Obviously, you identify what method is applicable to this Pfaffian differential equation. So we have the three methods. We have the five methods now to solve the Pfaffian differential equation. The first is what? All three variables are separable. The second one is what? One variable separable. The third one is the homogeneous Pfaffian differential equation. The fourth one is the Nathan's method, and the fifth one is uh, by reducing it to ordinary differential equation. So the last two methods, that is reduction to ordinary differential equation and Nathan's method, if the question is of this form, that find the solution of this equation by using Nathan's method or by reducing the ordinary differential equation, then we apply the last two methods. If the question is like this, that verify this is integrable and find its primitives or find its general solution, then don't think about the Nathan's method or the method to reduction of order. Just think about the first three methods. That is, all three variables are separable, one variable separable, or homogeneous. So this is the homogeneous Pfaffian differential equation. So apply the method that y is equal to ux and z is equal to vx, that method, and find the solution. All these problems are from your textbook, that is textbooks given in your syllabus. So these problems are important. So solve these examples. Y dx plus x dy. So it is one variable separable. 2z integration is z square, and y dx plus x dy is derivative of x into y. So by using that some tricks, we solve these examples. These are one variable separable or three variables separable. So solve these problems also. These are also from your, okay, the same problems, same problems. Okay, solve these problems. I think these are one variable separable or three variable separable, or if you observe this example, then it is a homogeneous Pfaffian differential equation. This is also homogeneous Pfaffian differential equation, that a y dx plus x dy plus 2z dz is equal to. But there is no need of applying the homogeneous Pfaffian differential equation. This is also homogeneous. This is also homogeneous. This is this yz plus hz xy. All are homogeneous functions of the unit. So either use that tricks that is used to obtain the solution, which is one variable separable or three variables separable, or directly apply the special methods, that is the homogeneous Pfaffian differential equation. So solution of Pfaffian differential equation in three variable by introspection, that is just observe and integrate. This is the some problems of introspection method. There is no need to apply the special method. Just simplify, and z dx plus x dz is derivative of x into z, and this is if you find that these two terms are derivative of y square by x, these two terms. So we have this answer. Then variable separable, all three variables are separable. So these are the examples of variable separable. If we divide by x square, y square, z square, we have this, that is the three variable separable. So one variable separable. So how can solve the one variable separable Pfaffian differential equation? Use that tricks. That is, separate that variables dividing by some quantity and separate the variable, and in order to the two remaining variables not separable, use the tricks given in the chart, previous chart. Homogeneous Pfaffian differential, that is substitute y is equal to ux, z is equal to x. So already this theory and all problems are covered in the previous discussion. Just take the example for this example for homogeneous Pfaffian differential equation and apply the method, we have this solution. So, and the fourth one is what? Nathaniel's method. Already the method and the problems are discussed in the previous lesson discussion. Then reduction to ordinary differential equation. So this is the PDF of your authorized textbooks that is given in the your syllabus. So integrate this in order we have to solve this z is equal to x plus ky by using the method to reduce this method, this example to ordinary differential equation. So this is the answer. This is the answer. Xy plus yz plus zx is equal to constant. So these are some mixed problems. That is, these are what? The question is what? Verify the following equations are integrable. That is, first show in each example of Pfaffian differential equation, first verify the given differential equation is integrable or not integrable by finding x bar dot curl x bar is equal to 0, and then find their primitives, that is their solution. So solve all these examples. Then these are some another examples, PDF of another book. This is not your authorized book. But these are the tricks to integrate some functions solution by inspection method. And first method, that is three variable separable or one variable separable examples are solved by using these tricks. Okay. So see, these are the some solved examples. Solved examples. So write all these examples in your notebook. Write the answer of these examples in your method. Only refer these solutions as a hint for the solution of the equation. X dy minus y dx divided by minus 2x square z dz. So this is one variable separable. Dividing by x square, we have this, and then x dy minus y dx divided by x square. Use these tricks. X dy minus y dx. Just observe this. X dy minus y dx divided by x square is derivative of y by x. Okay. So use this chart, these tricks, and solve the examples of Pfaffian differential equation. All these examples are either one variable separable or three variable separable. So write all these examples and their solutions in your notebook. All these examples for practice purpose. 2x z dx plus z dy minus dz is equal to 0. Again, one variable separable or it is three variable separable. Actually, three variable separable. This is 2x dx by if you dividing by z, then we have the solution. So these are the mixed examples of one variable separable and three variables separable. All three variables are separable. So this is the example, that is dividing by x square plus y square. This adding these first two terms, then take z as common and then dividing by z, we have this, and this x dy x dy minus y dx by x square is derivative is it is a derivative of log tan inverse y by x, log tan inverse y. So use the tricks, all these tricks, these formulas to obtain the solution of Pfaffian differential equation. So write all these problems in your notebook and their solutions. Don't write this problem 20 number problem. So these are the examples of three variable separable or one variable separable problems. So these are also examples for practice. All are Pfaffian differential equation in three variables. So solve these examples. Answers are given in this video. And then the third method, second method, solution of just that is all these problems are either one variable separable or three variable separable. Then homogeneous differential equation, homogeneous Pfaffian differential equation. So these are the examples of homogeneous Pfaffian differential equation. Y is equal to don't use this method, substitute alternative method. This is substitute y is equal to vx and ux and z is equal to vx. Y is equal to ux and z is equal to vx. Solve these examples by using that method. So y is equal to ux and v is equal to y is equal to ux and v is equal to zx vx. Okay. So just write this problem and solve this problem by using substituting y is equal to ux and z is equal to vx. Don't substitute x is equal to ux, uz and y is equal to vz. This is alternative method. So these are the all examples of Pfaffian differential equation, homogeneous Pfaffian differential equation. These are some exercise on the Pfaffian homogeneous Pfaffian differential equation. So their answers are also given. Solve all these examples. So this is about the topic Pfaffian differential equation. So there are five methods to obtain the solution of Pfaffian differential equation. First is variable separable, that is all three variables are separable. Second is one variable separable. Third is homogeneous Pfaffian differential equation. Fourth one is Nathan's method, and fifth one is what? Reduction to ordinary differential equation. So this is about the Pfaffian differential equation. So we will see the theorem, the proof of the theorem that Pfaffian differential equation x bar dot dr bar is integrable if and only x bar dot curl x bar is equal to 0 in the next lecture.